Good day. My name is Brent Insko, and I'm Lead XR Architect at Intel and the Working Group Chair for OpenXR. Today, I'll spend a few minutes covering OpenXR and its latest developments. For the agenda, I'll go over what OpenXR is, why it was needed, what's been going on with OpenXR, and where we're going next. OpenXR is a royalty-free open standard that provides high-performance access to AR and VR platforms and devices. OpenXR handles the communications between applications and XR devices. An XR platform, such as the Valve Index, Oculus Quest, or Microsoft HoloLens 2, provides the application information such as the head and hand position, information about the controllers and the input state, such as whether a button has been pressed or released, and also display configuration and form factor information, such as whether there is a single display or multiple displays. The application provides the XR platform an image or images to display, audio, and also haptic responses, such as vibrational responses for controllers. So why was OpenXR needed? Consider the variety of XR platforms available today. They range in display capability, tracking capability, environmental input capability, as well as controller style and input mechanisms. Before OpenXR, with so many platforms driven by proprietary software interfaces, it increased development time and the cost for application developers trying to reach a broad XR audience. Separate paths had to be developed for each of the VR platforms that a developer wanted to release on, a path for each of the different vendor-specific interfaces. The results were that some titles would appear on one platform before others, or that some titles might only appear on one platform, period. This fragmentation across platforms also increased validation overhead and therefore cost. With different code paths comes more opportunities to introduce bugs and bugs that would only appear in one of the paths and not others. This increased the testing time to ensure the quality of the applications being released on each platform. This increased time and resources spent developing one title impacted the developer's ability to create more titles. With the development of OpenXR, application developers can now program to a single common high-performance API, which supports all the major VR platforms and some of the AR platforms. OpenXR is an extremely flexible API. It supports both AR and VR devices. It supports both devices tethered to a PC and all-in-one standalone devices. And it supports devices running different OSs from Android to Windows. This is a high-level overview of a possible OpenXR application, and it's just to give an example of the flow of the program and the steps involved. I don't have time today to get into the details, so I encourage you to check out our GitHub repository and member company sites for sample code to start from, which I will show at the end of my talk. Here's another good overview of the OpenXR API, and it can be found in our reference guide, which shows the flow of an OpenXR application and where the different function calls typically are called. So then let's talk about the latest developments in the OpenXR ecosystem. OpenXR continues to accelerate its growth. It began development in early 2017. 2 years later, we released the 1.0 specification after developer and community feedback from a provisional release. 2 years ago, we released the Conformance Suite and launched the Adopters program. Since then, we have seen more and more XR platforms adopt OpenXR, and most recently, we're seeing applications take advantage of the cross-platform support of OpenXR. As mentioned, we're seeing widespread industry adoption. Our conformant implications include the HoloLens 2 and mixed reality headsets from Microsoft, and the HoloLens 2 includes support for the hand and eye tracking extensions. From Meta, we have support across the Rift S tethered to the PC, as well as their all-in-one standalone devices, the Quest and Quest 2. From HTC, we have the Vive Focus 3, Cosmos, and the Wave Runtime. Valve supports OpenXR on the Steam VR platform. All of Vario's headsets are fully conformant, and we have an open source implementation called Monado, released from Collabora. We also have widespread engine support from the Unreal Engine from Epic, as well as the Unity game engine. And just recently, we have support in the core of the Godot game engine as well. Qualcomm is also releasing support on their XR developer platform associated with Snapdragon Spaces this spring with full OpenXR support. We also have over 97% of the PC VR systems tracked by Steam VR have support for OpenXR. Beyond just supporting OpenXR, all the major platforms have publicly announced that future development on their platforms will take place using OpenXR rather than their own proprietary APIs. The number of companies that publicly support OpenXR continues to grow as more than 50 companies see the benefits of developing AR and VR applications and platforms around a cross-platform, high-performance API. Now let's look at some of the applications that are beginning to use OpenXR. Minecraft will use OpenXR to provide VR support across all OpenXR devices. Microsoft has also launched VR support in Flight Simulator using OpenXR. Blender, the open source 3D rendering engine, has incorporated OpenXR for use in VR scene inspection. And OpenXR is also used across all of the Chromium-based browsers for supporting WebXR, the browser-based XR API. Both Microsoft Edge and Google Chrome web browsers support WebXR using OpenXR. And here is an example of VR scene inspection in Blender. We also have a major franchise game that launched last year that uses OpenXR for cross-platform support. Zombieland VR, based on the movie, is a game built using Unity with OpenXR support in a single executable for all of the PC-based VR platforms. It is now supported across 27 different VR platforms. So what's next for OpenXR? So while we have a stable core OpenXR 1.0 specification, we continue to add support and explore new AR and VR features through extending the core API. When launched, there were 16 KHR extensions that were released in conjunction with the release of the 1.0 specification. Today, OpenXR now has over 80 extensions, exploring a number of features including scene understanding for AR, locomotion, foveated rendering, and expanding user input capabilities. So let's talk about a few of the extensions. One of the features added is overlay support. Overlays allow multiple in-world applications in OpenXR. This allows one app's 2D content to be layered on top of an existing application's content. This enables rich content into other XR applications. Use cases for this include displaying the desktop OS windows in your XR world, in-game heads-up displays, virtual keyboards, and enabling video chats while traveling between planets, as shown on the right. This is currently an experimental extension just to prove out the concepts and get feedback on whether the APIs provided are the right ones. We also have a real hand tracking extension. This enables tracking all of the joints in the hands to provide a rich interactive experience with gesturing with the real user's hands. This represents about 4 months of work across all of the platforms, which had their own ways of accessing information about the positions of the hands. Here is an example of hand tracking using StereoKit on top of OpenXR with an Ultraleap developed API layer running on the Windows Mixed Reality runtime. Beyond the hand tracking extension, we also have an AI gaze tracking extension, which enables eye gaze interaction for applications for more intuitive interfaces. Together, these extensions enable developers to build cross-platform applications that use advanced user interface solutions. So what's in the future for OpenXR? We continue to clarify and fix a few things from the 1.0 specification. We're looking to expand support for augmented reality and mixed reality by looking into providing applications more information about the scene it's being presented in. And we're also looking at additional user input and output capabilities, such as expanding haptic support, body tracking support, and more controllers and device support. OpenXR is also looking to the future of the location of computing and providing portability as AR is deployed on new platform architectures, such as edge servers. One architecture being developed uses 5G to connect a lightweight AR device to send its real-time sensor data to an edge server that's processing that sensor data and generating graphical augmentations, much more sophisticated than could be generated on a battery-powered device. And these images are sent back to the device for display. The OpenXR API can hide these round trips over 5G from the application, enabling the same AR application to run natively on an AR device or an AR device connected to an edge server. So how do you get started? You can jump to the OpenXR landing page. And if you have questions or feedback, you can let us know in the OpenXR forum or on the Khronos Slack channels. From the landing page, you can get to all of the available resources regarding OpenXR. This includes a 200-page specification, reference pages of the functions, and an overview guide depicting the life cycle of an OpenXR program. We also have a number of GitHub repositories where we keep the latest developments with the specification, including documentation, header files, conformance test suite, and sample code. We also have great support from the OpenXR working group companies who are providing their own information about best practices, common issues, and samples for developers to get started. And just to give a heads up, Khronos also has multiple standards that are being widely adopted and used in augmented reality and virtual reality because they help solve the challenges faced by all XR applications. You have Vulkan and WebGL for cross-vendor 3D graphic support across GPU and the web. You, of course, have OpenXR for portable XR. And you have GLTF, KTX, and the 3D Commerce working groups, which are looking to support cross-platform 3D assets for efficient deployment and display of models and scenes. One of the reasons that OpenXR is gaining such wide industry support is that it's a win-win for all involved. Software developers or ISVs win because they can write an application once and ship on multiple hardware platforms without reporting, saving time and money and reaching a much larger audience. XR hardware vendors win because they expose the OpenXR APIs on their platform and have access to a much larger library of OpenXR compatible applications. And most importantly, end users win as they will know that the XR applications they want to run will be compatible with the system they have purchased, growing confidence and the XR market for everyone. With OpenXR on an HMD near you, now is the time to get involved and use OpenXR. As our support continues to grow across platforms, game engines, and games, OpenXR will only get better and better. Thank you.